So first I want to explain a little bit about what radian measure is and where it comes from. So if we have a circle with a central angle, that just means an angle starting at the center of the circle and going to the edge, that cuts off an arc equal in length to the radius, then the measure of that angle is 1 radian. So a radian is the size of the angle so that the radius r and the arc length, we call that s. So it's saying when your radius is equal to the arc length, your angle is 1 radian big. So if we want to find the radian measure of your angle, all you have to do is take your arc length divided by the radius. So the angle in radian measure is arc length divided by radius. How many multiples of the radius is that angle? That's how many radians it is. When we're doing that, the radius and the arc length would have the same units, so it would be in inches or centimeters or feet or whatever. And so when you divide them, those units cancel, so radians technically don't have a unit written beside them. So that's why if I see 30 without a unit, I'm going to assume you mean 30 radians, which is very different than 30 degrees. So technically, any number without a unit from now on, we assume is a radian. So if I just look at this example, if you have a central angle theta in a circle of radius 3 centimeters that cuts off an arc length of 6 centimeters, what is the radian measure of our angle? So what I know is my radius is 3 centimeters, my arc length is 6 centimeters. If we want to find our angle, I just told you, you take the arc length divided by the radius. Okay, when you divide those, the centimeters cancel. That's why I said it has no unit. So 6 divided by 3 is 2. So that angle is 2 radians. You're welcome to write the word radian beside it, but you don't have to. If I see it without a unit, I am assuming it is radians. So the calculation is very simple there. You're just dividing the distance on the outside of the circle by the radius. And it's a little more concrete than degrees that we're used to, because we just have this arbitrary, a line is 180 degrees, a circle is 360 degrees, and we just accept that. But this is an actual measure where we can divide it and make that calculation. So if I have 2 different ways of measuring angles, radians and degrees, we have to be able to go back and forth between the 2 of them. So I'm going to figure out that conversion. I want to, instead of just telling you what it is, I want to show you why it works out that way. So we know our angle, I told you, was S divided by R. If you make a full rotation all the way around the circle, your arc length is the total distance around. What is the total distance around the circle called? Circumference. How do you find circumference? circumference is 2 pi r. So if I'm talking about the situation where I go all the way around the circle, my arc length is the entire circumference, which is 2 pi r. Alright, well, in this case, we know if you go all the way around in degrees, that's 360 degrees. Here, those r's cancel, so 360 degrees has to equal 2 pi radians. Well, if you divide by 2, 180 degrees is equal to pi radians. That is the conversion that we'll use. So to go back and forth, we have to know 180 degrees is pi radians. Any questions, sir? So I'm going to use that to convert some of our common degrees into radians. So 45 degrees. We've done some unit conversions before. We talked about just multiplying by a fraction. If I have degrees and I want them to cancel, it has to go on the bottom. And I know 180 degrees is equal to pi radians. So we're going to multiply by pi over 180. Okay. When we do that, we want to keep it in terms of pi. So don't put the pi in your calculator. If you're just multiplying across, we get 45 pi over 180. Or if we reduce that, 45 over 180. Give that to me as a fraction. So we'll write this as pi over 4. So 45 degrees is pi over 4 in radians. If I want to convert 450 degrees into radians, again, if we want degrees to cancel, we just put them on the bottom. So we multiply by pi over 180 degrees, that cancels those degrees. So we just have 450 pi over 180. Or give me 450 over 180 in lowest terms. Pi over 2. And that pi just stays in our answer. A lot of times our radian measure will have pi's in it, but it doesn't have to. So, something to keep in mind. Alright, we might have decimals, but it's the same conversion. If I wanted to change it 2 degrees, and multiply by pi over 180 degrees. This gives me negative 78.4 pi over 180. I do negative 78.4 over 180. That does not turn into a real nice fraction, but we have one, so it's negative 98 pi over 225. Sometimes we're going to have some that are just ugly. In that case, you can also multiply out the pi. Most of the time we don't, especially if it's something nice like pi over 2. If you're getting a really ugly fraction, if you take negative 98 pi divided by 225, so using the pi button on your calculator, not estimating it at 3.14, that gives us negative 1.9. 0.683. So it doesn't have to have a pi, it could be multiplied out. We just try to keep as nice of a number as possible. So if we're getting a decent fraction, we'll just keep it in terms of pi. Any questions on that? So we could also go the other direction, where I give you radians and I want degrees. What do you think we would do here? When we wanted the radians, we multiplied by pi over 180. Taking pi over 6 times 180 over pi. In this one, those pi's cancel. So you just have 180 over 6. Or 30 degrees. We have 4 pi over 3. Take it times 180 over pi. So 4 times 180 divided by 3. I get 240 degrees. And make sure you are putting a degree symbol on those, because they are degrees. That's different than radians. And if I don't see that symbol, I'll assume it's radians. Last one, negative 4.5. Remember, it doesn't have to have a pi in it to be radians. It just doesn't have a degree symbol. So even though there's no pi here, I'm assuming that is radians. So if you multiply by 180 over pi, you can do negative 4.5 times 180. And that gives us, what? Negative 810 over pi degrees. Or if you're getting an ugly answer like that, you could just go ahead and divide by pi as well. If you divided your pi, you get a negative 257.831 degrees. So those are equivalent. You can keep the pi in it or divide it out. Any questions there? Figure out what you're doing. Most people drop that negative, but you got yours, so that wasn't your issue. Most of the people that had a problem on that graph dropped a negative. You had it.
Is that what it's supposed to look like?
Pretty close. It should be flattening out as you get to your horizontal. But oh, because of ridges. Still decreasing the curve there. So you're almost there. Dang it. Almost.
I thought it was weird that it was crossing like that.
Thank you. You're welcome. All right. Any questions about converting between degrees and radians? You either multiply by pi over 180 or 180 over pi, depending on which one you need to cancel. So, if we are going to have radians, we need to be comfortable with both radians and degrees, and for the common angles. So we are going to start what's called, you're welcome, a unit circle. Now this is just the beginning. Today we're just working on the degrees and radians on it. If you've ever looked at the ceiling, you might see a circle up there. You've probably seen other students with it. We're not jumping into the full thing right now, but what we're going to do is talk about common angles right now. So unit circle just means a circle with a radius of 1. Okay? If you were, think about a normal XY plane, like we did in college algebra. If I wanted to circle of radius 1, centered at the origin. So here's the center, this is the radius 1, this is the circle I'm talking about. Okay, that's the unit circle. We're just taking an in-depth look at that circle itself. So these lines represent the x and y axes. And we should know what those common measurements are. This would be 0 degrees. What's this going to be? This one would be then this would be 270 degrees. Okay. The other lines that we have measured off. This is about a third of the way between 0 and 90. What do you think that one is? 30 degrees. This one is 2/3 of the way. What do you think that is? We have 60 up here and 45 in the middle. Because that 45 is right in between 0 and 90. So these are those same angles we should be very familiar with because we are using them on our hand trick all the time. 0, 30, 45, 60, and 90. Okay. Let's go ahead and talk about these in radians for a minute. So I want to put degrees and radians on here. If we want radians, we are taking our degree times pi over 180, right? So if I have 0 degrees, what's 0 times pi over 180? 0. If I have 30 degrees times pi over 180 degrees, what does 30 over 180 reduce to? So that would be pi over 6. Okay, 45 degrees. So if you take 45 times pi over 180, so you do 45 over 180 and then stick the pi back on your answer, what do we get? Okay, 60 degrees. So 60 times pi over 180. 90 degrees. So 90 times pi over 180. So these are the common angles. That means I might tell you 45 degrees or I might say pi over 4. They're the same thing. If you're looking at a circle, it's this angle right here. They are identical. It's the same thing as if I say 12 inches or 1 foot. It's the same measurement both times. Okay, so pi over 6 is the same thing as 30 degrees, just 2 different measurements for the same angle. All right, let's get these angles. So when I'm looking at these, we haven't done this in a circle, but we've seen a lot of these angles before. This line right here has a reference angle of 30 degrees. That means its distance from the x-axis is 30 degrees. So if I wanted to find that angle, I would have to do 180 minus 30, which is this line represents 150 degrees. Okay, the next one. This has a reference angle of 45. So if we think 180 minus 45, we get 135 degrees. This is a reference angle of 60. So 180 minus 60 is 120 degrees. And remember, those are distance to the x-axis, always. All right. Let's go ahead and just finish off our degrees, and then we'll come back and do the radians. If I'm looking in the third quadrant, this is a reference angle of 30. So all of these lines right here, the reference angle is the same. All of these are 30 degrees from the x-axis. So if I'm talking about this angle right here, we would do 180 plus 30. Oops. 210 degrees. All right. The next one. All of these angles have a reference angle of 45. They are 45 degrees from the x-axis. So 180 plus 45 these lines. These are all 60 degrees from the x-axis. So 180 plus 60 is 240 degrees. In the fourth quadrant, 0 degrees is the same as 360. So when my reference angle is 30, we have to think 360 minus 30, which is 330. And my reference angle is 45. 360 minus 45 is 315. And 360 minus 60 is 300. So those are all the angles that I've been quizzing you over, asking you what is the sine of 315 degrees or tangent of 210 degrees. Those were the common angles between 0 and 360. Are we okay with those degrees? You guys know where I got them? If I handed you a blank circle, could you find all those angles again in degrees? All right. If you have the degrees, then radians aren't too difficult to get. You're just multiplying by pi over 180. You can do it in the calculator, just leave off the pi. We want our answer as a fraction. But we're going to pick up on some patterns in a second once we do that. So if we come down here, what is 180 degrees? If you multiply by pi over 180, just pi. And we actually found that out earlier. We said 180 degrees was equal to pi. All right, 150. If I go to my calculator and I type in 150 over 180, I'll put that as a fraction in lowest terms. We get 5 pi over 6. Okay, for 135, if I do 135 over 180 in lowest terms, what do we get? Right, if I do 120 over 180 in lowest terms, let's go to the third quadrant. If I do 210 over 180 as a fraction, 225 over 180. And 240 over 180 turns into 4 pi over 3. Okay. 270. So 270 over 180 gives us 3 halves, so 3 pi over 2. 300 over 180. $315 over 180. Gives us 7 pi over 4. And 330 over 180. So, now the question is, do we see any patterns? If you look at all my orange lines that I drew, everything with a reference angle of 30. What's your denominator on your fraction? 6. If the reference angle is 30, it's always going to be over 6. When the reference angle is 45, what's the denominator? 4. All the 45s were over 4s. When the reference angle is 60, what's the denominator? 3. All of those have a denominator of 3. Okay. These 0, pi over 2, pi, and 3 pi over 2. We can really think of them as multiples of pi over 2. 1 pi over 2, 2 pi over 2 is, 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2. If you go all the way around, 360 degrees is the same as 2 pi, or 4 pi over 2. There's a lot of other patterns we could talk about. You know, in the first quadrant, the numerator is just pi. So pi over 6, pi over 4, pi over 3. In the second quadrant, what's the relationship between the numerator and denominator? The top is 1 less. Because if you think about your reference angle, we did 180 minus 30. So it's like pi minus pi over 6. So the top is 1 smaller than the bottom. What's the relationship in the third quadrant? 1 more, because it's like pi plus that. Fourth quadrant, it's a little less obvious. 11 and 6, 7 and 4, 5 and 3. You see what it would be? To get those, your reference angle is 2 pi minus each of those. So it's double the bottom minus 1. 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. So there's a lot of patterns. That means these radians are almost easier than degrees. If I say 7 pi over 6 and ask you for the reference angle, all you have to think about, well, it's over 6. Anything over 6, the reference angle is 30 degrees. So when we're trying to decide our reference angle, sometimes people were tempted to go to the x-axis. In these, in radians, all you have to do is look at your denominator, and it'll tell you. So anytime the denominator is 6, you're talking about 30 degrees. Anytime the denominator is 4, you're talking about 45. The denominator is 3, you're talking about 60 degrees. Okay. I think I'm going to stop for today. So I'll go ahead and give you guys, but I'm not giving you all of this yet. Want you to do these. What does EOE mean? Every other even. So it's like 30, 34, So Monday we will finish